Welcome to the latest edition of Reimagine podcast series. I'm here with Paul Bromnick. Paul is a supervisor in our large data and advanced methods group. Paul, maybe explain a little bit for the viewers and listeners. Everybody talks about large data and advanced methods. What do we mean with that?
Sure. What we're looking to do in this area is to see how we can optimize testing. So how to improve testing, make it more efficient by trying to get away from using real physical hardware and moving towards a virtual world. So we're trying to inject simulation and mathematics into what was traditionally a very hardware-driven process. Mm-hmm. So we're trying to bring math into that scenario and making things more efficient, such that we don't have to absorb all the costs of changing hardware as you go through the development process. Sure. So that's what we're trying to do, and we have a range of tools and systems in place to inject that virtualization from the desktop right through to all the testing platforms, right through to the vehicle testing. Yes. So a range of different software solutions and methodologies to do that.
So the challenges I'm aware of, or I know, is everybody all of our customers want to, if possible, right, go to 100% virtual testing.
Yeah.
You can give me an answer here, how realistic that is. But I believe the key piece is the fidelity, the accuracy of the models we have, right? And for that, you need data. So how do you get this data to bring into the model if you don't do actual physical testing? So can you shed a little bit of light on that? And again, give me an idea what you think. Is 100% possible? Is 50% virtual possible?
Yeah. Yes, it needs. The question often is, how good's the model? The question is that we respond with is, how good does it need to be? So it depends on what you're doing. Yes, you need data from physical hardware to validate the models. So the important thing really is that the philosophy of using models is adopted into the whole process, not as an afterthought. And often what happens is the idea to go virtual comes in too late, by which time all the testing's been done, and it's kind of an add-on, and you don't get the full benefit. If you build in the strategy from the start, so you're developing your hardware as you're building your models, then it becomes more ingrained in the process, and there's more potential for benefits in terms of time and cost and quality. So it can't be an afterthought. It has to be built in. Of course, the more money you spend on the models, the better the models are going to be, the more useful they're going to be. So it's a compromise you have to decide. It's an engineering judgment as to how far you go with getting the models as good as they can be. But certainly, it's not just about spending money. It's about changing your philosophy, how you think about development.
And again, if we go back and say, some of our customers have made it publicly known they want to get rid of any physical type testing.
Yeah.
But I mean, in testing, don't you have to have the model, let's call it almost perfect? I know you mentioned for some, the model needs to be as good depending on what you want to do. But if I want to replace physical testing with virtual, then my model has to be 100% accurate. Or what am I missing here?
Number one, if you're just testing one piece of hardware, you've just got one specific piece of hardware. That doesn't give you any idea of the variation of the population. So you might be calibrating so there was a risk that if you just calibrate on one vehicle, that that becomes that fixes everything in stone, and you've calibrated a solution which doesn't take into account variation, part-to-part variation, changes over time, etc. So just testing in hardware can be dangerous from that perspective. Whereas in the modeling world, you can introduce variability much more easily. You can do much more part-to-part variation, and it's much more easy to implement and cheaper. I think there's always going to be a need for physical testing. I don't think we're going to completely replace that. What I would like to be able to do is make that testing far more targeted, so that we don't have to do everything in the physical world, and the virtual the results we get from the virtual calibration and virtual testing points us more targetedly to a better solution when we do the physical testing. So we're not just doing everything physically; we're just going to do more specific, targeted areas. So you get the most out of our fleet, and hopefully a smaller fleet and less test trips.
Sure.
So that's the goal. But I don't think we're going to replace it completely.
So where we are right now? Where are the most advanced customers we work with at when it comes to the division between physical and virtual testing? Are they at 50%? Are they at only 30% virtual testing and still 70% physical, or just on a high level? I know it depends on component to component or system, but
it's still tricky to pick a number. I would say between 20 to 50%. I think
physical testing.
Physical testing.
Okay.
It's an uphill battle always. Take your eye off the ball, and it will, because certainly in calibration world, they'll veer towards the vehicle rather than the virtual much more readily.
Okay.
Because that's what they've always done.
Yeah.
So there's a whole mindset change that needs to happen in industry for that to take place. But I think until you've taken away vehicles and they have to go virtually, there's always going to be a tendency to go and sit in the parking lot and do it. So there is that.
And when do you think the majority of people will, let's say, be at 50% physical, 50% virtual? Are we looking at another 10 years? Are we going to look at maybe the next 2 to 3 years? Just how do you see the industry moving and adapt? I think the big point you made is it's a mindset change, right? It's a cultural change. It's something we haven't done in the past.
Yeah.
And maybe the younger engineers coming out of school are much more used to it. So it's kind of a blending until they
it's a generational
take over,
thing.
right? A generational thing.
Yeah, because there's many guys that in calibration departments have been sitting there for 25 years doing exactly the same thing. So it's very much more difficult to change them.
Yeah. When is the industry going to be at, let's say, 50%? Is it taking another 5 years? Is it?
It's always being pushed in that direction.
Okay.
The problem I think at the moment is there's so much change happening in the industry, right? Such a lot of changes happening that there's opportunities. So as people go to the BEV and the hybrid world, there are opportunities to accelerate the virtual solutions because they're necessary, because there's so much more complexity. So there's definitely a push in that direction. But I think, like you say, I think with the generational change, as those people get into management positions and they believe in the benefits of virtual, it's going to be easier. Yeah. I think for the old school people, it's a bit more tricky.
For you and I, more difficult.
Yeah, that's right. Yeah.
So maybe let's switch and go to a topic that right now everybody's talking about: artificial intelligence. How much do we at AVL use it, and how much in what you're doing, again, trying to move from the physical testing to the virtual testing, does AI play a role?
Yeah, it's there's a huge potential to treat each vehicle like an iPhone, where you can upload all the information and then download new software, and that's with those, especially with batteries. So with the batteries, if you can understand how the user is using this vehicle, you can optimize how he manages his battery on a very individual level. So it's very customized. So it's just like an iPhone to some extent. So that's the way it's going. But then there's lots of barriers and problems and cybersecurity and data management and all that kind of stuff. So, but the potential is huge. So there is a huge activity in that area, and it's also driven by customer demand. They want to have everything in their vehicle, and want it to be bespoke and customized, and we see that with the Teslas, where you wake up the next morning, you've got a new set of software downloaded. So it's going that way, and it all does kind of link in with the virtual too, because the idea is, one of the ideas is to build a digital twin of the vehicle, your specific vehicle. So if they have that in the cloud and they can understand exactly how you're going to use the vehicle, they can really give you the right software. So I think there's again a huge change that's coming. Sure. Yep. So I see. I mean, AVL has a lot of experience worldwide in that area. So, and we're trying to siphon it into our little department here and get more exposure to it. But it's a lot of customers are asking for that.
I also was under the impression that when it comes to AI, again, the big piece obviously need a lot of data, right? So the system can learn and grow and create new opportunities, new possibilities. But I always thought that, at least generally speaking, it's not a problem that we don't have the data. It's the problem is how do we mine it? How do we mine that ever-growing lake of data, that data lake? Yeah. Is that true, or do I see this wrong? Is the challenge in getting data, or is the challenge in getting the right data, or is the challenge really no data and the right data we have? The problem is how do we mine it? What is the data proper to use for this and that?
I think you're right. The problem is mining the information we need. What information can we gather from this huge amount of data that's available? So there's no problem in getting data. There's more data than you can ever need. It's how to manage it and pick out from that the KPIs that are important. So that's so metadata. Having metadata to help you to mine what you're looking for is a big area for data handling, data management. That's a big area. But it's only getting data isn't the problem. You can there's as much data as you could ever need, but finding the nuggets of gold in that data that can help you understand whatever you're trying to achieve, whether it's understand the customer's usage or whether trying to optimize different routes or whatever it's going to be. So it's a lot big area too. Yeah.
So we talked about virtual testing, virtual calibration, just virtual related to testing and simulation and calibration of propulsion systems, ADAS systems, whatever it might be, right? Customization that you just mentioned for entire vehicles that we talked about, the software-defined vehicle.
Yeah.
How much speed can we pick up with that? I know there's a tremendous amount of complexity that your team also has to deal with, but how much faster will this allow the industry to move? Where today we talk 6+ months easily for testing not only components but entire systems and subsystems, and that maybe just be the beginning, right? But as we're pushing to get vehicles out fast, as we're trying to follow let's say the cell phone industry that comes up with a new cell phone every 6 months if they want it, and we're trying to chase this because we don't want to drive around in 2, 3, maybe 4-year-old technologies. Why we don't want that, I don't know, but we just always want the latest, right? So how much speed do you really think we can pick up with what your team is doing? Are we talking weeks? Are we talking months? Are we talking years? Give us an idea here of what we're...
Depends on it depends. Depends on the size of the program, of course. If it's a huge program, then there's potential to save like maybe half a year. And improve, and with improved quality, that'd be the goal.
And improved quality.
Yeah, that's the goal. So, and the reason for that is you're delaying the onset of building hardware. So you're doing as much as you can virtually. So it's much more easy to iterate on design and hardware systems and integration. You do that all virtually before you get any hardware. Yeah. Then you slowly start to introduce hardware, and then you re-optimize, and then you introduce more hardware, re-optimize, until eventually, when you actually get to the vehicle, everything's been you've thought through everything, such that you have a very targeted test plan with the vehicle, and there's no more like crap, the director's driven the car and it sounds like shit, we've got to go back and do it again, and redesign the exhaust system, and then you have to or there's an emissions issue that is not not discovered late in the day, it's discovered much earlier. So you're reiterating. So that's where the time and the cost savings come in, and the speed, ideally. Yeah.
So if I envision a future where our models are almost perfect, data is not an issue, we have more data than what we could probably use or need, is ultimately the bottleneck to produce a new vehicle really is the actual production, getting the physical material, getting the physical, whatever, battery cells, e-motors, engines, whatever it might be, and assembling this. It's not anymore the design. The design essentially is you press a button, you enter a few KPIs of what this vehicle is, the size, speed, range, whatever it might be, and the next day orders are going out to material suppliers and that come in. Can I envision it that way, or is this?
I think eventually. I think with the number of different battery manufacturers and different control system manufacturers and different levels, different software suppliers, there's always going to be an integration of hardware. Sure. It's going to be a thing, right? It's ever going to just come together and operate correctly from the start. So there's.
But with AI, we should be able to do that, no? I mean, being a little provocative here, obviously, but...
we'll see. I don't know.
You don't sound too confident, huh?
I don't know. They're going to take over the world, aren't they? So the cars will be fighting back. I don't know. That's going to happen. But there seems to be a lot of hype about AI, and so I don't know yet. Let's see what happens. But I'm not too worried about that. The fundamentals haven't changed. Still have to. What we found when we go into large OEMs is they have modeling departments and calibration departments and design departments. The problem is always bringing them all together so that you have a microclimate of simulation, design and calibration under the same umbrella. Right. And that's very difficult to achieve organizationally, and that's why they struggle. With AVL coming, we can create that microclimate instantly in that company and hopefully start to diffuse outwards, and that is where what we found works. But that's the problem that they have to overcome is organizationally how to bring those things under one system. Because traditionally they're all very diverse. Yeah. The modeling team do their thing, the calibration team do their thing, the design team, development team, they're all kind of individual departments. Yeah. That's what has to happen. And that I think is is the challenge. Okay. Yeah.
So you shared a little bit, I think, how far this technology, the simulation, the data analytics, the ability to do more and more virtual calibration testing, virtual generally speaking, right? What do you see? What excites you over the next 5 years? What do you see happening over the next 5 years? Is it just kind of incrementally going? Is there suddenly we hit an inflection point and suddenly we go from, you mentioned at the low end 20 and everybody switches to 60%? What do you look forward to over the next 5 years, I guess?
I think I'm looking forward to developing. So my background's mostly ICE, so internal combustion engines, and Hill, and personally moving into the BEV space and the ADAS space and the hybrid space with the Hill, I think is for me going to be interesting and exciting, and then also bringing in just the data intelligence side. So everything it's changed. The whole world's changing with regards to data and how information is shared between vehicles and between infrastructure and vehicles, and the way that's heading. There's so much research being done right now and development that you're not really seeing yet in the marketplace. But I think it's coming in the next couple of years. So it's going to change how we use and think about our vehicles. So the world's changing. The work we have to do to support that, and we're still kind of being defined. We're still trying to work out exactly what is going to happen. But certainly I think one thing's not going to change is that the people are going to want to do. They're going to need to do things as cheaply as possible, and with as much quality as possible, as quickly as possible. Mm-hmm. So I don't think that's going to change. So I think that's where the philosophy is still going to be of bringing in virtualization is still going to be critical. I think the ones who can get it to market first with a proven robust product developed as intelligently as it can be, they're going to be the winners. I think. Yeah. So. Okay. That's how I see it, but it's going to be very interesting for the next few years.
Maybe the last question for you: when at AVL we work with almost every OEM in the world to one degree or another, some a whole lot more, some a little bit less. When we're talking about data intelligence and how that is used, is there a big gap between our customers that use it very, very heavily and the ones that are using it, but maybe from a mindset, a culture, a process, haven't really switched over? Or is the gap between what you would consider the leaders and the rest, is it shrinking? Is it small, or is there a big gap? Is there a lot of opportunities for the majority of the industry, or is everybody they're all pushing this forward fairly quickly, or is there a big gap between early adapter or not?
So I must admit, I'm new to this. Data analytics is a new thing, but my impression is that so far is that some of the OEMs have really taken this data analytics very seriously and putting a lot of effort into it and development cost into it. And I think they're leading the way. I think that they're going to lead the way and push the technology. And I think the newcomers are going to kind of come in behind that and learn from what they're learning because of the large investments they're making. So I think the OEMs are some of them are particularly very keen on really developing and they're working with the Department of Transport and all these different opportunities that are occurring. They are really pushing those opportunities and seeing what's possible. But I think the smaller companies are going to follow in behind. I think that's how it's going to work from what I've seen.
And you see that across, maybe I guess really last question now, you see that across OEMs and suppliers, or more on the OEMs that are pushing more this data analytics for components, systems, subsystems?
Yeah, I think it's definitely being pushed by the OEMs. It's just the prognostics and taking that data and predicting warranty issues and that kind of thing. I think that the OEMs are really investing into that, and that's where the money is. I think the suppliers are obviously they're looking at it, seeing what's happening, and looking for where opportunities are. But I think that's how it's going to go. Yeah,
it's kind of driven then probably by the return of investment, right? If you invest a lot in data intelligence to avoid recalls or avoid quality issues, that's where you get your biggest bang for your buck, and that's what they focus on.
Yeah, for sure. Yeah.
Okay. All right.
Yeah. Okay.
Thank you, Paul.
Okay. Thank you.
And thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.